Hello and welcome to this video about the Gesswein MFM hard disk drive emulator. There's a shortage of information on the internet about how to initially set up and configure this hardware and get it running, so I wanted to put that right at this stage for the purposes of doing a data archive, creating an image of a hard disk drive. Obviously the board can also then be used to emulate that hard disk drive once you've archived it, but this is the first set of steps, getting the image itself. So what we have here is a Seagate ST225 20 megabyte hard disk drive. It's been fully tested. It has DOS 6.22 installed on it. As you can see, we've got standard power connectors and the MFM cabling at the back. In addition to that, we also have a spare ATX power supply here that I'm going to use to drive this hardware, both for the MFM board itself and also for the disk drive. Finally, we have a standard Windows 10 PC. We have Terraterm installed on that, which will act as the console software, and also we have a USB port that we can plug into to hook up the console to the MFM emulator. So looking at the MFM emulator itself, this is the underside of it, and it consists of basically two boards. First of all, the smaller board under here is a BeagleBone green board that's provided, and you'll see that it has a 4 GB SD card, micro SD card in here, with the software preloaded from Gesswein, and furthermore it has a couple of other things plugged in. We've got a 8 GB USB stick here that will be used for transferring the images across from the BeagleBone onto the stick, and they can then be loaded onto the Windows machine, stored and examined. I mentioned the console, and here we have also a USB connection that comes down to here, and we will plug that into the USB port on the PC at the appropriate point, and that will give a connection through to the Terraterm session that we've configured to run with the BeagleBone, and you'll see those settings in a minute. So you have the BeagleBone green, and it is plugged in on its headers to the Gesswein board, the larger board of the two. You'll see that I have fitted some nylon feet, screw-in feet, which are basically there simply to allow the board to stand clear on the desktop. There are a few things to mention on the top of the board. First of all, power must be provided by the ATX power supply. It would attempt to take power from this USB serial port on the BeagleBone, but it's not going to have the current required, and so you shouldn't be relying upon that. Use a separate ATX power supply, standard 12 volt 5 volt connector. We can see that the MFM cables from the Seagate drive are simply plugged into these connectors at the bottom, and there are some jumpers that are worth mentioning. First of all, there's this one here which is marked on the board as being drain and fill, At the moment it's set to drain. That is a bleed resistor. That means that when you take power away from the board, these capacitors here, which are designed to provide enough power for an orderly shutdown in the event of power failure, these capacitors are drained when you switch the power off, which prevents the opportunity to get an electric shock from these terminals here. Only once you have got your board set up and configured the way you want it, and you want to permanently install it in a machine, for example, would you then change this jumper from drain to fill, so that the capacitors are left fully charged when the power is taken off. So that's the first thing to mention. The second thing is that you have another jumper over here which is labelled right, and if that jumper is across the two terminals, then it means that the hard disk drive is no longer write protected. It can be written to. We certainly don't want that, and in most cases you wouldn't. You want to make sure that the hard disk drive is write protected. You're going to be trying to archive it after all, and so you would have the jumper effectively taken off. In this case it's just been stuck onto one of the two pins. So that with that jumper off, it means that you are write protected. Now, in terms of powering on and powering off the system, it's quite important to do it in the right sequence. As far as power on is concerned, I've written myself a little note here. You switch the ATX power supply on here. You connect up the USB cable here, and then on the PC you wait for the disk drive that's on the beagle bone to be recognized, and it will come up on the screen here as a new drive letter and blank content. At that stage you can use TerraTerm to log into the system. On this label I've put PuTTY, but I'm actually going to use TerraTerm as the console software. So what we'll do is we'll have a go at that and get ourselves to the stage where we've got a login prompt. So first of all, we put power onto the ATX. We can hear the Seagate drive spinning up. At the same time we can see that the beagle bone has recognized the USB stick, and it's busy going through a boot up sequence. I'll now connect this USB serial port, which is going to act as the console. I'll pause the video for a second, and at the same time I'll launch a TerraTerm session. So here we are with the USB serial port to the beagle bone connected to the USB port on the PC, and the PC has now recognized the USB stick as drive F. We don't need that, so we'll close that, and I've launched a TerraTerm session here, and it's come up with its initial parameters. Here we're going to be using the serial link, and I've checked that that serial link we connected it to the beagle bone is COM11 in my case. So if I say OK to that, then we can see that we've come up with the login prompt on the beagle bone. However, I also have a configuration file here which helps to tidy things up a bit. So if we go into setup and restore setup, I've created a saved configuration called Gesswein MFM Emulator. I'll load that, and that's basically just giving me a session with parameters like the font size that I want, the window size I'm going to work with, and how it's going to deal with auto wrapping text, for example. So if we looked at setup terminal, we can see that new line, the receipt of a new line character, will be treated as a carriage return line feed rather than just what the default is, which is a carriage return. And what that does is effectively gives us text wrap, line wrap, which we'll need for some of the long commands that the David Gesswein software uses. So that's our terminal session, and if we hit enter, we can see that we have the login prompt. The login default is root with full admin privileges, of course, and there's no password. So here we are, we're now into the BeagleBone, and it's waiting for us to enter some commands to begin the archiving process. We can see that the state of the machine is we have the ATX power supply on, we have the USB stick is active, we can see that the BeagleBone green is running, we have power being supplied from the ATX PSU to the David Gesswein board, and we also have power being provided to the Seagate ST225 from the same place. So I'm going to pause the video at this stage, and then I'll take you through running some of the commands on here that will actually analyze the disk and create a archive image for us. Okay, so we can see that on this URL here, which is on the David Gesswein website, there's a section to do with disk reading, and there are some Linux commands that we can use to actually read the data from the drive, create the image. So the first command is cd /MFM. Sorry, /MFM. Takes us into the MFM directory, and then we have setup MFM read. And that tells us that we're running a Rev C board. And then we have a couple of choices. We can either run a command to analyze the disk to try and work out what it is and create the image, or if we happen to know the information such as the cylinders and the heads, then we can run a different command to create the image. I want to show the analyze function here in this case, even though we happen to know what this drive is. So I'm going to type all of this in and give it a go. I'll pause the video while I do that. Okay, so the command which will analyze the disk drive has been typed in. You'll see why we changed the text wrap here, because it's gone across the 80 characters and carried on the next line. The last part, which is the file name, is of your own making. I've called it SC225, and then the serial number on the drive itself. If you can see that very clearly, but that's where I've taken that information from, and that will act as the identifier for the image. So finally, on to the exciting bit of giving it a go. We'll hit enter and see what happens. Okay, so it's off and running and going through the cylinders. There are 615 on this drive, and we can both see and hear that on the disk itself and the BeagleBone running software. So we'll let that run through, gets to 615. So having analysed the disk, it's worked out what the heads and cylinder information are, what the sector length is, and now it's actually creating the archive image. It's going to take a little while to run through, so I'll pause the video and come back when we get to the 615 mark. Okay, so it's finished the data extraction, and if we have a look, it's found cylinders 0 to 614, head 0 to 3, sector 0 to 16. It expected 41,820 sectors, and that's what it found. No bad headers, no bad data. Looking fairly good. So at this point we can go and have a look at the image that's been created. Running the ls-l command does a listing of the files in this directory and gives us the file sizes. We can see the one that we were looking for, called ST225, etc. And we can see from this that it's got 21 megabytes of data that it's extracted, and so we have our image. The next thing we want to do is to copy that image from its current location, which is on the BeagleBone SD card, and put it across onto this USB stick here, ready for transfer to the PC. So the first thing we want to do is to format the USB stick. When we booted the system up with this stick installed, the system automatically created a device for it in the /dev directory called SDA by default. So we need to make sure that first of all that is not mounted on the system. And so what we can do is run the umount command to check that. So we run umount space /dev/SDA, and it comes back and says it's not mounted, which is fine. And then we want to make a file system on this, i.e. to format it. And to do that we're going to use mkfs, make file system, .vfat, which is DOS compatible, -i /dev/SDA. That command will format the entire contents of the USB stick for us. And we can see that that's now finished. And at that point we can mount this onto the Linux file system. To do that we use mount command, so mount /dev/SDA, and the mount point, which part of the directory tree structure do we want to put it on? Well, in this case the default is /mnt. How do we know that's worked? Well, we run the command again, and this time we pipe, using the pipe command, the output to grep /mnt, which is the mount point. That comes back and tells us what's on that mount point, and we can see it's our vfat file system. If it had come back with nothing here, then the mount has failed. Okay, so we've now got a USB stick that's properly formatted, and we should be able to list any images on that mount point by using the ls command. So if we used ls/mnt, what we should find is it's empty. There's no files on the USB stick. What we want to do is to copy the file that we've got in this directory at the moment onto there. So we're going to use the cp command to do that, and we're going to copy the file called st225-615-84935, and we're going to copy that onto the mount point that we've created, which is /mnt, which of course is on the USB stick. So if we hit enter to that, we can see that it will be copying across onto there. It's actually quite quick. So give it a few seconds to do its job, and then let's run the ls command again on /mnt and see if there are any files on there this time. And we can see that we've successfully copied across the 21 megabyte hard disk drive image. Okay, so at this point we can now close the machine down, and we can transfer the USB stick across onto the PC. So the way that we'll do that is we use the Alt -P command. I can type in the right box. So it's Alt -P, and this will take the system down pretty rapidly, so we need to be ready to remove the power from the ATX power supply as soon as this machine goes down, and also remove the power by breaking the console USB link, because it will attempt to take power from there if it can. So if we hit enter, we can see that the system's going down. It's now down. So what we need to do next is switch the ATX off and then break the link. Okay, so I've unplugged the USB stick from the side of the beagle bone and put it into the USB port that was being used for the console. We can see that on the PC that's now come up as a new drive letter, and we can see in that drive that we've got the copy of the image on the USB stick. Okay, now we want to be able to copy that image off onto a suitable location on the PC where we can store this image for future reference. And if we, for example, go into here, create a new folder called Archives, and then paste the file in, we've now got a copy on the hard drive that we can then back up in the normal fashion on a permanent basis. Now, one very useful tool for exploring these kind of images is WinImage. Have a look at that. And we can use this software to open the image that we just created, which is on the D drive in Archives. So if we open that, it tells us that we've got more than one partition on this USB stick. So we'll select the 20 megabyte one, make it read only, and hey presto, Here we can actually explore the contents of the hard drive image itself, and we can see that they are the sort of standard MS-DOS 6.22 files that we used when we formatted this ST225 drive. So that brings this demonstration to an end. I hope you found it useful as a means of quickly putting the equipment together, getting a hard drive connected up and extracting the data from it in the form of an image, putting it onto a USB stick, bringing it across onto your PC, and then archiving it for the future, as well as being able to explore the contents and copy out individual files and so on if you need to. Thanks for watching.